12 seconds.
Ready to start? Hello everyone. We are the wind turbine for hurricane wind mitigation and power generation. I'm Marcos, I have Joel and Junior with me. Problem statement, first of all, there is a lack of innovative engineering solutions to mitigate the damage and destruction caused by hurricane winds. And secondly, the power generation is extinguishing our planet's natural resources. And we're trying to address both problems with this project. First of all, let me tell you a little bit about the uplift effect. On your top right, there's a picture that shows that wind striking a house at a 90-degree angle, and you can see how these vortices form. These vortices create a very high pressure difference, and the uplift effect is produced with this pressure difference. At the bottom, you can also see in this picture the wind striking the house with an angle on the corner, and there are two vortices formed, and these vortices again create this uplift effect. These are a couple of pictures of, the first one on the top is the prototype that has been already built, and the one on the bottom is the CAD model of it. Just some basic dimensions. We have 3 blades, we have an angle twist of 90 degrees, left some space in the middle to save material and cost. And you will explain the impact of this project.
So even though our initial prototype is pretty simple, we are expecting a pretty high impact with this project in general. Environmental, because we're using a renewable energy source, which is the wind. We are targeting global impact in all tropical countries that are annually affected by hurricane, and also in an economic impact, since we are reducing the cost of electricity producing from the wind and reducing the losses that hurricanes generate when those impact. The design consideration, we're taking into account first safety of humans and animal wildlife, the efficiency and service of the turbine, noise pollution of course, because we are planning on installing this turbine close to the roof of the houses, and if it is noisy, then it makes no sense at all to install it. Reduction on the cost, of course, because we are targeting countries in development that need to generate electricity in a safe and low-cost way, and aesthetically appealing because we are, of course, installing the houses and people are not going to like it otherwise. Then the simulation results. This is our first simulation using CFD analysis. Since this is a new approach of wind turbine and wind mitigation, we go ahead and start mixing the optimization process with the design. And this is our first analysis without the device and with the device. We can see the same scale of pressure in the middle, and the results of a reduction of around 30% while placing the device. This reduction is also translated reduction in the uplift effect. So now Junior is going to explain the experiment.
Thank you, Joel. As we mentioned before, we have a prototype built already. So what you guys see here is a picture of, we model a flat roof of a building with the prototype being used. We were looking into the impact of the wind, in this case 90 degrees straight to the device, and as you can see there is less scarring as velocity increase by using the device, which is something that we want to see if it's going to work or not. This is a quick video. We're also looking into looking at different places that we can place the turbine, and we're very concerned about the corners, which is a critical place. And as you can see there is almost 70% improvement by using the device, because the scarring stays the same there. But in this side, which is there's not device there is a lot of scarring just going away. The wind is impacting the device 45-degree angle, and it's about 10 meters per second. Since this is a new approach, we're planning to do some optimization in order to reduce the uplift force effect and also to maximize power generation. While doing the optimization, we have to take into account different variables such as dimension of the turbine, how many number of blades, shape, etc., as well as we want to use CFD, and also we're planning to use the wall of wind to actually test the turbine. We want to say thank you to our advisor, Dr. Tremandes, as well as our PhD candidate, Javier Palencia, and also to the personnel for Wall of Wind at the university. Thank you very much. This concludes our presentation.
Yes, any questions? I couldn't see your timeline and cost analysis.
Yes,
Do you
And it's in
have,
the report, but
You need to
yes,
put
we
them
know, we
here
should
too.
include it in the presentation as well.
Yes.
Absolutely. Thank you.
But you have to include that on the slide as well.
yes.
No, I got it.
In the modern prototype, I see that it's like length is almost same to the roof.
Yes.
You know?
Yes.
So you're planning to make like such a big.
Well, what we did was we create something to see if it works, and as we can see, we proved that it works. What we did was a scale of the prototype from 3 to 1 in order to actually model this, and this was presented, by the way, in a competition last week in Orlando.
We still have to, of course, further consider that
Yeah.
we want to test using CFD and an actual prototype, different positions, different sizes, different length, and then decide which one's the best. according
But
to
the model is fixed, dimensions and the shape is fixed.
Yes.
Yes.
This
So now it's-
Actually, we have two, yeah. It's fixed for prototype and most of the analysis, but we understand that houses are so different
Yes.
and we have so many type of roof that we cannot target just one type of roof. We're trying to investigate a little bit more in this type of dynamic wind mitigation and power generation at the same time. So basically that's.
They have to
our-
optimize the blade design as well.
Exactly.
You can see the prototype is just a flat blade,
Yeah.
with its just rotational effects. The older effects like viscous effects or boundary layer effects, they will come later. They have just shown the first stage of the problem.
Yes.
Thank you.
Any other questions?
Thank you.
Thank
All
you.
right.